we're going to look at the difference between emission spectrum and absorption spectrum. And these spectrum are an important part of how scientists figured out the electronic structure of an atom, or how electrons sort of exist in an atom. So this is a graphic of how we get emission spectrum. A gas of a given element, such as neon or helium or hydrogen, is placed in a gas tube, and the gas that is in the tube is basically zapped. A high voltage is applied to that gas, and it sort of acts as a light bulb. It begins to glow. And if we take the light from that heated up gas and put it through a prism, what we will see are very specific wavelengths of light that are always the same for a given element and very different from any other element. So scientists didn't really know how to explain this phenomenon. And we'll look down here at some emission spectrum of different elements. So when we take hydrogen gas and we heat it up and then put that light that it emits through a prism, we see very specific lines of color. And these lines have very specific wavelengths, very specific frequencies, and we'll see very specific energies. Helium, on the other hand, if we heat it up and put it through a prism, it will show a different emission spectrum with colors at different wavelengths. And here is the emission spectrum of neon. So astronomers first used this type of signature to determine what elements were actually in stars. So now let's look at absorption spectrum. Absorption spectrum occurs when a specific gas is exposed to a light, and it's not necessarily hot. So I like this graphic because it has the difference between emission and absorption on it, but this gas sort of doesn't have a container, and of course it has to have a container. So we have a container of a specific gas, and we shine a light on it, and then the light that comes from that gas is put through a prism. We have an absorption spectrum. So it looks just like the emission spectrum, it's kind of like the opposite of it. So wherever there's a line in the emission spectrum, there's a black line in the absorption spectrum. So what that means is a photon of light with this same exact wavelength is being absorbed. So depending on the circumstances, this gas will absorb a wavelength of electromagnetic radiation, or a photon of electromagnetic radiation of a very specific wavelength, or it will emit it. And any given element is going to have a characteristic emission and absorption line spectrum, and wherever there are lines in the emission spectrum, there are going to be black lines in the absorption spectrum. So here's another example. Here at the top is a continuous spectrum. This would be the rainbow of colors, and raindrops actually act as a prism to show us the continuous spectrum of visible light. And then down here is the emission spectrum and absorption spectrum for a given element. Wherever the lines are in the emission spectrum, there is a black line in the absorption spectrum. So what you will be expected to know is the difference between absorption and emission. Absorption is when a gas is absorbing light of specific wavelengths, and this is shown by the black lines in the spectrum. An emission spectrum is when a gas is heated up and emits light of specific wavelengths. And as I stated earlier, for any given element, the emission spectrum is going to have lines of color in the same exact place where the absorption spectrum has black lines, and each element has its characteristic signature spectrum, whether it's emission or absorption.